Dear students, I am Angad Naik, Assistant Professor, Department of Mechanical Engineering, SGBIT, Belagavi. Welcome you all to session 7 of Module 5 on spur gauge and gear trains. In this particular session, we will discuss on the number of teeth on pinion in order to avoid interference. So let's start the session. In the figure, there is pinion and wheel. Pinion is here, wheel is here. Wheel has center O2, pinion has center O1. Pinion also has base circle, pitch circle, addendum circle, and there is maximum addendum circle of the pinion. Similarly, the wheel has base circle, pitch circle, addendum circle, and maximum addendum circle of wheel. The line joining O1 and O2 is the center distance between wheel and pinion. The pitch circle of wheel and pinion cuts at point P. This is called as point of pitch point, or the common point between the two pitch circle. The base circle of wheel is here, the base circle of pinion is here. So the common tangent between M and N, this line MN is the common tangent between the two base circle. Now, in order to avoid interference, the addendum circle is here for pinion, and for wheel it is here. This addendum circle for the two mating gears must cut the common tangent, which is this common tangent from M to N is the common tangent, must cut the common tangent to the base circle between the point of tangency. So they should cut at the point of tangency. This is at point M and at point N. So these are the 2 points of tangency. The limiting condition reaches when the addendum circle of pinion and wheel passes through point N and M. That means the maximum value, limiting value, will be N for pinion and it will be M for wheel. Let's denote each element of the figure. Let small t be the number of teeth on the pinion. Let capital T be the number of teeth on wheel. Let small m be the module of teeth. Let small r be the pitch circle radius of pinion, which is given by m, which is module, into t, number of teeth on pinion, divided by 2. G is the gear ratio given by capital T by small t, which is nothing but capital R by small r. Phi being the pressure angle or angle of obliquity. Now we need to start with the derivation. We'll first apply cosine rule for the triangle O1, N and P. Let's begin. From triangle O1, N, P, applying cosine rule, we get O1 N whole square is equal to, that means it is O1 is here, O1 N square is equal to O1 P square plus Pn square minus 2 times of O1P into Pn into cos of the angle formed by O1Pn. So the angle formed is this much. So this is 90 degree till here, and from here to here it is phi. So this angle is 90 plus phi. So it is cos O1 Pn. Now from the figure it is obvious that the term O1 P square is smaller. O1 P is the smaller. So O1 P square is R square. Pn is from here to here. So this is again by Pythagoras theorem we can find what is the angle formed with sine phi. So Pn can be written as R square sine square phi, then minus 2 into O1P. O1 and P is this small r, into Pn is R sine phi. As I said, cos 90 plus phi is the angle formed at this point. So I have written Pn is equal to O2P sine phi, which is nothing but R sine phi. Let's proceed to the next step. So this we have seen in the previous slide. Now we shall continue from here. This cos 90 plus phi is nothing but sine phi with a negative sign. So that negative sign and here negative sign will turn into positive. So it becomes R square plus capital R square sine square phi plus 2r sine square phi. From this term, if you keep r square common, you will get 1 plus r square sine square phi divided by r square plus 2 times of r sine square phi divided by small r. Now if I take capital R by small r common, then I get r square into 1 plus r by r is common. So it is r by small r plus 2 and then into sine square phi. The limiting radius of the Pinion addendum circle should be equal to O1n, that is small r into square root of 1 plus r by r into r by r plus 2 into sine square phi. So we have assumed that r is equal to mt by 2. So we'll replace r by mt by 2, and then gear ratio G is equal to capital T by small t. So that is equal to r by r. This we have seen in the previous slide. So we'll replace the r by r term by capital T by small t, and hence we get this equation. Because O1P is equal to R, which is mt by 2. Let APM be the addendum of the Pinion, where AP is a fraction by which standard addendum of one module for the Pinion should be multiplied in order to avoid interference. Now from the figure, the addendum of the Pinion should be equal to O1n minus O1p. In this term, O1n is this, for which we have retained this equation, minus O1p. So for this equation, if I minus subtract O1p, then I'll get the addendum of the pinion. Therefore, it is AP into m is equal to mt by 2 into square root of 1 plus t by t into t by t plus 2 into sine square phi minus, this is that term, mt by 2. If you further simplify, we get mt by 2 into square root of 1 plus t by t into t by t plus 2 into sine square phi minus 1. So mt by 2 is taken as common. On left hand side there is ap into m, so in the next step we'll cancel this m and this m on left hand side and right hand side, so we'll get ap is equal to t by 2 into the whole term is same. Therefore I can take t on left hand side and equate to the whole term. So t is equal to 2 times of ap divided by the whole term. This is nothing but the final equation, but in simple terms we can rewrite this as this capital T by small t can be replaced by g. Here also capital T by small t can be replaced by g. So the final equation can be further simplified as t is equal to 2 into ap divided by square root of 1 plus g into g plus 2 into sine square phi minus 1. Now let's move on to minimum number of teeth on wheel in order to avoid interference. The figure is almost same. The triangle that we now consider is for wheel. Now that is marked in red color. So it is O2P M, this triangle we are going to consider. Let's start. Capital T be the minimum number of teeth required on the wheel in order to avoid interference. Also let A suffix W into M be the addendum of wheel, where A suffix W is a fraction by which the standard addendum for the wheel should be multiplied. Now we shall apply cosine rule to the triangle which is marked in red color, that is O2MP. To this triangle we will apply cosine rule and see the derivation. This is the extract of the figure. Now we shall apply the cosine rule. Applying cosine rule, we get O2M square is equal to O2P square plus PM square minus 2 times of O2P into PM into cos of the angle formed by O2PM. So O2 is here, P is here, M is here. So again the angle formed here is 90 plus phi. So we rewrite the equation as r square plus r square sine square phi minus 2r sine phi cos 90 plus phi. Then we can further write this cos 90 plus phi as sine phi with a negative sign. So that negative sign and this negative sign will turn into positive. So the equation becomes r square plus r square sine square phi plus 2r r into sine square phi. This can be written as r square is taken common, and rearranging the terms we get 1 plus r square sine square phi divided by r square plus 2r into sine square phi divided by r. Now again few terms are kept common, so small r by capital R is kept common here, so we are left out with 1 plus r by r into r by r plus 2 into sine square phi. Now the limiting radius of wheel addendum circle is O2 m is equal to r into square root of the whole term what we had here. The same term is coming under the square root. So the capital R is replaced by small m into t by 2. Again the terms are replaced by the gear ratio, that is small t by capital T. So that is the change that you find here. Now we know that the addendum of the wheel is equal to O2m minus O2p. So substituting the values of O2m minus O2p, we get this equation: AW into m is equal to mt by 2 into square root of 1 plus small t by capital T into small t by capital T plus 2 into sine square phi minus this is O2p, which is mt by 2. Next we'll further simplify, keep the terms common, that is mt by 2 is kept common, and we get this equation. Then on the left hand side there is AW into m, so this m and the left hand side m get cancelled. We are left out with AW is equal to t by 2 into the whole term. Next, capital T is equal to 2 times of AW divided by the whole term. I can replace small t by capital T as 1 by g and rewrite the same equation as this final equation. Capital T is equal to 2 into a suffix w divided by square root of 1 plus 1 by g into 1 by g plus 2 into sine square phi minus 1. This is the final equation for minimum number of teeth on wheel in order to avoid interference. Now we'll formulate a table and try to see the minimum number of teeth to avoid interference. This is with respect to pinion. So there is a table showing different system of gear teeth and the minimum number of teeth on the pinion required. Then we have the final equation that we have already derived for pinion and for wheel. Now if the pinion and wheel have equal teeth, then the gear ratio will become 1, that is G becomes 1. Now if I substitute the value of G is equal to 1 in the above equation, then the equation reduces to small t is equal to 2 into AP divided by square root of 1 plus 3 sine square phi minus 1. If the same thing is applied for the wheel, then we get capital T is equal to 2 times of AW divided by square root of 1 plus 3 sine square phi minus 1. Hope you have understood the minimum number of teeth to avoid interference. This is the end of the session. Thank you for your patience hearing. Thank you.